You know that feeling when you're staring at a problem and it just seems so huge, so complicated, you don't even know where to start? Well, today, we're going to look at a really elegant mental shortcut that makes those kinds of intimidating challenges, well, surprisingly simple. Let's see how it's done.
Okay, let's jump right in with a little challenge. I want you to try and solve this in your head, right now. Find the sum of all the whole numbers from 30 all the way up through 39. And hey, no calculators. Go ahead, give it a shot.
Kind of tough, isn't it? Your brain's trying to keep a running total, add the next number, remember where you are. It's a lot to juggle. But what if I told you there's a beautiful, almost ridiculously simple way to get the answer in just a couple of seconds?
So, what's the secret? Well, it's got nothing to do with being a math genius. It's all about using a really powerful problem-solving technique. You just look for a simpler, related problem to solve first.
This is the core idea right here. Instead of trying to wrestle with the big, messy problem head-on, you find its smaller, much more manageable cousin. You solve that easy one first, and then you use that answer as a stepping stone to solve the real problem.
All right, so let's actually apply this method to that first challenge I gave you, finding the sum of the numbers from 30 to 39.
So, here's our game plan. First, we're going to find an easier problem. Instead of 30 to 39, how about 0 to 9? Way easier. We solve that. Then we just figure out the difference between our two problems and combine everything for the final answer. It's a nice, clean, step-by-step approach. So step 1 is solving our simple problem. What's the sum of the numbers from 0 to 9? A lot of you might just know this one off the top of your head. It's 45. Easy. That's our foundation. Okay, now for the clever part. How do we connect this back to our original problem? Well, our list from 30 to 39 has 10 numbers in it, and each of those numbers is exactly 30 bigger than its counterpart in our simple list. You know, 30 is 30 more than 0, 31 is 30 more than 1, and so on. So the total difference is just 10 times 30, which is 300.
And now for the final, super easy step. We just take the answer from our simple problem, which was 45, and we add that total difference we just found, 300.
And boom, 345. There it is. No frantic adding in your head, just a really simple, elegant way to get to the right answer. Way easier, right? And you know, we can even do a quick gut check here. All 10 of our numbers are around 30, so the answer has to be a bit bigger than 10 times 30, or 300. And they're all less than 40, so the answer has to be less than 400. Our answer, 345, fits perfectly right in the middle. Makes sense. Okay, that was pretty cool. But you might be thinking, sure, that works for a list of numbers, but what about other kinds of problems? Well, let's put this technique to the test with a totally different kind of puzzle. All right, here's the new challenge. You've got 100 pennies, and you've got some very specific rules for how to stack them up. Stack 2 has to be double stack 1, and stack 3 has to be double stack 2. I mean, where do you even begin with that?
We're going to use the exact same strategy. Let's find the simplest, smallest possible version of this problem. What's the smallest set of stacks we could make that still follows the rules? Well, what if stack 1 had just 1 penny? Then stack 2 would have to have 2, and stack 3 would have 4. This little unit of stacks, 1, 2, and 4, uses a total of 7 pennies.
So the next question is, how many of these little 7-penny units can we make out of our total of 100 pennies? Well, that's just a division problem. 100 divided by 7 gives us 14, with a little bit left over. That means we can make our base unit 14 times. Now we just scale everything up. We multiply each stack in our tiny starting unit by 14. So the first stack is 14 times 1, which is 14 pennies. The second is 14 times 2, so 28 pennies. And the third is 14 times 4, which is 56 pennies.
And hey, remember that remainder from our division? That tells us how many pennies are left over. After we make our 3 stacks, we've got just 2 pennies remaining. Problem solved.
Okay, let's just take a step back and look at what we just did. We used the exact same core idea to solve 2 problems that, on the surface, look completely different from each other. The big takeaway here is that solving a simpler problem first is so much more than a math trick. It is a full-blown mental model. It's a way to handle that feeling of being totally overwhelmed by a big challenge. Think about it. Planning a massive project at work? Start by just planning out one single perfect day. Training for a marathon? Just focus on running 1 good mile. Each of those small wins builds momentum, and it turns what looks like a giant mountain into a series of small, manageable hills.
And that's the real power of this idea.
It reframes these overwhelming challenges into a series of steps you can actually take. It's a tool for turning that feeling of paralysis into real progress, not just in puzzles, but every single day. So the question I want to leave you with is this. What big, complex problem in your life is just waiting for you to solve a simpler version first?